Hello students, welcome back to the math class. In our last session, we have discussed about the concepts of Euclid geometry, the axioms, the postulates. So students, a system of axioms is called consistent. If it is impossible to deduce from these axioms a statement that contradicts any axiom or previously proved statement. So when any system of axioms is given, it needs to be ensured that the system is consistent. After Euclid stated his postulates and axioms, he used them to prove other results. Then using these results, he proved some more results by applying deductive reasoning. The statements that were proved are called propositions or theorems. Euclid deduced 465 propositions in a logical chain using his axioms, postulates, definitions and theorems proved earlier in the chain. In the next few chapters on geometry, you will be using these axioms to prove some theorems. Now, let us see in the following examples how Euclid used his axioms and postulates for proving some of the results. Okay? Now, let us go through the examples given in your book. So, example 1 says that if A, B and C are 3 points on a line and B lies between A and C, then prove that AB plus BC is equal to AC. So, the figure is given in your book. Let us draw it on the board. So, students, as given in your book, I have constructed a line which has 3 points A, B, C lying on it. So, these 3 are called collinear points. From axiom 4, we know that the points which, or we can say that the things which coincide with each other are equal to each other. So, in this case, we can clearly see that AC is a line segment, AB is a line segment and BC is a line segment. So, what happens? So, what happens with AC? AC is nothing but the combination of AB and BC. That means AC is equal to AB plus BC. But why we can say that AC is equal to AB plus BC? Because AB plus BC, which is a line segment itself, okay? AB plus BC coincides with AC. That means these are two things which are coinciding with each other, so they are equal to each other, okay? So, we can come to the conclusion that AC is equal to AB plus BC by using the axiom 4 of Euclid, okay? Students, let us discuss example 2. What it says? It says, prove that an equilateral triangle can be constructed on any given line segment. This is the line segment AB, and here you need to do some construction. So, why we should do construction? We need to prove that we are getting an equilateral triangle, and from this line segment it is to be proved that this line segment is to be used and an equilateral triangle is to be constructed. So, we can refer the postulate 3, which says that any circle can be drawn or any circle can be constructed with any point and any length of radius. So, if I take this as the radius, okay, I have 2 points actually, A and B. So, if this is the radius, I can draw 2 different circles using line segment AB. How? Let us see. See, if I take A as the center, so AB will be the radius, isn't it? If A is the center, AB is the radius, and I can construct like this. So, I can go from A to B, and if I go anti-clockwise or clockwise, I can construct a circle. Again, in the second instance, if I take B as the center and BA as the radius, so I can construct another circle like this. So what you can see that they are intersecting at point C. Let that point be C, okay. So if this is the circle, okay, if this is the circle having B as the center and BA as the radius, we know that the radii of a circle are equal in length. That means if this is the center, this is the circumference of the circle, so this is another radius. BC is another radius of the circle having center B. Same way, if I take A as the center and this is the circle we construct, then I can say that AC is radius of that circle. So AC is radius. Now what we have found? AB is the given line segment. We have taken AB and BA as two radii and we have constructed two circles so that we can get two different radii AC and BC. BC is equal to BA, okay, and AB is equal to AC. I can write BA as AB, okay. So BC is equal to AB and AC is equal to AB. Can you recall something? Just guess. Yes, there is one axiom, okay. There is an axiom of Euclid which says that if two things are equal to another thing, two things are equal to another thing, so they are also equal to each other, isn't it? So here BC is equal to AB, AC is equal to AB, that means AB is equal to BC is equal to AC. That means the given line segment AB, the line segment AC and line segment BC are equal to each other. So as we know that the equilateral triangle has three equal sides, isn't it? So here we were given a line segment AB and we have constructed a triangle ABC, triangle ABC, and we have proved that AB is equal to BC is equal to AC. So by following such process, we have constructed an equilateral triangle with given line segment AB. Hope you have understood this concept. Okay, let us move to next example. Students, let us discuss theorem 5.1. It says two distinct lines cannot have more than one point in common. Let us go for the proof. Here we are given two lines L and M. We need to prove that they have only one point in common. For the time being, let us suppose that the two lines intersect in two distinct points, say P and Q. So you have two lines passing through two distinct points P and Q, but this assumption clashes with the axiom that only one line can pass through two distinct points. So the assumption that we started with, that two lines can pass through two distinct points, is wrong. From this, what can we conclude? We are forced to conclude that two distinct lines cannot have more than one point in common. Let us do it. There is a line L and suppose this is a line M. This is L, this is M. So now there are two distinct lines and they do not have any common points till now. But we know that straight lines, they go to infinity. So if I produce this line segment like this and if I produce line segment L like this, so they will meet at this point. Suppose this point is O. So now point O lies on L and M as well. So they have only a single common point. You can very well see from this diagram that there never lie any other point which is common to both L and M. There are so many points on this line M, there are so many points on line L, but there is a common point which lies on both L and M, that is the point of intersection, which is O in this case. Okay, hope you understood this theorem. Students, let us discuss exercise 5.1. So students, bit 1, it says only one line can pass through a single point. Let us have a point. Let this be point O. Okay. So let us draw a line. We can see that there is a line, it passes through this point O. But it's not true that only this line is passing through the point O. We can have multiple lines which can pass through this point like this. We can have n number of lines passing through point O. So the statement that is given only one line can pass through a single point is false. Next bit is there are an infinite number of lines which pass through two distinct points. We have 2 points, suppose P and Q. We know that these points can be called collinear if they lie on a single line. So when I draw a line through P and Q, we can clearly see that P and Q lie on the single line, isn't it? So the statement is saying that there are an infinite number of lines which pass through two distinct points. There are an infinite number of lines which pass through two distinct points. So this statement is also false because there is a single line passing through two distinct points. Suppose I have a point over here, so I can say that these 2 points lie on another line. Same way, these 2 points lie on another line. Suppose this is M, so I can say that P and M lie on line, suppose this is L. Q and M, they lie on another line, suppose this is X, and M and Q lie on the line X, and P and Q, they lie on suppose another line named Y. So 2 points, they lie on a single line. Okay, so 2 points, they lie on single line. So the statement there are an infinite number of lines which pass through two distinct points is false. A single line passes through two distinct points. Okay. Bit 3 says that a terminated line can be produced indefinitely on both the sides. We have already seen in the postulate of Euclid that a line segment can be produced indefinitely on both sides. So this statement is true. Bit 4 says that if two circles are equal, then their radii are equal. Isn't it so? If two circles are equal, then their radii are equal. So students, if two circles are equal, then they are coinciding with each other. That means they are equal. So equal circles, they have equal radii. So this statement is also true. Bit 5 says that in figure 5.9, if AB is equal to PQ and PQ is equal to XY and AB is equal to XY, it is said that AB is equal to PQ, PQ is equal to XY and XY is equal to AB or AB is equal to XY. Okay? AB is equal to PQ, PQ is equal to XY, AB is equal to XY. Isn't it true? Let us check it out. See, AB is equal to PQ and PQ is equal to XY. So, we know that things which are equal to the same thing are equal to one another. That means AB is equal to PQ and xy is equal to PQ. So, AB is equal to xy. So, this statement is also true. Okay? Students, question number 2 says that give a definition for each of the following terms. Are there other terms that need to be defined first? What are they and how might you define them? Bit 1 is parallel lines. So, see this scale, okay? There are two lines which are going parallel to each other. Can you see that? These two lines, the upper one and the lower one, they never meet with each other. We can define that parallel lines are those lines which never meet with each other or they never intersect each other at any point. Another way of saying this is that parallel lines are those lines which maintain a perpendicular distance, okay? Perpendicular distance between each other, okay? So, if I draw two lines, that means these points, the perpendicular points, when I join those points, I get similar or exactly same length. So, these all lengths are equal to each other. So, they are maintaining a perpendicular distance between themselves. Suppose this is line L and this is M, I can say that L is parallel to M. Clear? Next one is perpendicular line. I hope you have already understood this concept from the previous concept. Perpendicular lines means they are maintaining 90 degree with each other, or we can say both the lines intersect each other at a right angle. Let us draw it. Suppose I draw a line like this and another line intersects that line at 90 degree. So, I can say that suppose this is line L and this is M, I can say L is perpendicular to M or M is perpendicular to L, because they are intersecting each other at 90 degree. So, how we can define perpendicular lines? Perpendicular lines are the lines which intersect each other at right angle. Okay? Next is line segment. Line segment is a part of straight line with a certain length, isn't it? So, suppose there lie a line L and AB are 2 points lying on this line, having a distance of 5 centimeter between each other. So, I can say that AB is a line segment. Okay? AB is a line segment which is nothing but a part of line L. So, line segment can be defined as a part of line having a certain length. Okay? Next is radius of a circle. Radius of a circle. What does it mean? We know that a circle has a center. So, the distance between the center of the circle to its circumference is called your radius. So, if this is a circle having center O and this is the distance between the center and the circumference of the circle, suppose this is A. Another point on the circumference, suppose B. Another point on the circumference is suppose C. So, OA, OB, OC all are equal in length and these are called radii of the circle having center O. Radius OA, radius OB and radius OC. So, we can define radius of a circle as the distance of the circumference from the center. from the center. Next, square. What is a square? Square is a special kind of quadrilateral. Why is it special? Because a square is having 4 equal sides and the 4 angles of the quadrilateral are all 90 degree. That means we can define a square as a quadrilateral having 4 equal sides and each angle of the quadrilateral should be 90 degree. Because we know that there is another quadrilateral having 4 equal sides, that is your rhombus, isn't it? So it should be specified that all the angles of the quadrilateral having 4 equal sides have to be 90 degree. So square is a quadrilateral having 4 equal sides and all the angles are right angle. Okay? So students, let us discuss question number 3. It says that consider 2 postulates given below. First one, given any 2 distinct points A and B, there exists a third point C which is in between A and B. What it says? So it says given any 2 distinct points A and B. Suppose this is point A and this is point B, and if I join those 2 points, I get a line segment AB. There exists a third point C which is in between A and B. So let us take a point C over here. So as per postulate, it says given any 2 distinct point A and B, okay, there exists a third point C which is between A and B. Second postulate, there exists at least 3 points that are not on the same line. If we consider line segment AB, so point A and point B, there are 2 distinct points A and B, and the postulate says that there exists at least 3 points that are not on the same line. So we can have a point C over here. We can definitely have a point C over here. So the question says that do these postulates contain any undefined terms? Exactly. It has some undefined terms like your point, line, okay. These are not defined in these postulates. We can say that these postulates contain some undefined terms like points and lines. Second question asks that are these postulates consistent? We can answer it as yes. See, from the diagram we can see that as per the first postulate, A and B are 2 distinct points and C is another point which is lying between A and B. So it is absolutely fine. As per the second postulate, A and B are 2 distinct points and C is another point which is not lying on the line segment AB. So there exists at least 3 points, those are A, B and C, that are not on the same line. So we can say that yes, these postulates are consistent. The third question says, do they follow from Euclid's postulates? No, they are not following Euclid's postulate, rather they are following one of the axioms of Euclid. Fine, hope you have understood. Students, this is it for today's class. We have gone through the examples and we have gone through the bit number 1, 2, 3 of your first exercise. Revise the concepts related to the example and the exercise. We will go through all other questions of the first exercise, and in our next class we will go through other questions of the first exercise and move with some more concepts from the chapter. Till then, keep practicing, keep smiling. Thank you.